I need to evaluate what is the complicated part of this problem and what do I want to take out. So, yep, that's fine. It's integral of x squared plus 1 squared 2x. Now, I will admit that this is one where you could avoid using u substitution if you wrote this twice and FOILed it and then distributed the 2x if you'd want to. I am going to show you how to do u substitution so you have more tools, but there are some that you could avoid. Example 1, we could not avoid u substitution. Example 4, we will not be able to avoid it. This one we could, but we're still going to use it just as another example to see how it works. So there's two problems with this one. Number 1 is it's a product. We cannot antiderive a product. Number 2 is it's a composite function. We've got this x squared plus 1 squared. So we've got the function x squared plus 1 inside another function squared. So that makes it also another reason why we can't do the antiderivative right away. What you want to do is pick the more complicated part and take it out. So don't make u equal 2x because that's not as complicated as this part. What I'm going to do is take out the x squared plus 1 because that then will get rid of the composite. I'm hoping the product rule also disappears as we work through the problem. So I'm going to take out x squared plus 1 and have that be my u. So it was x squared plus 1 squared, now it's u squared. 2x is still there. The dx I have to get rid of. I'm going to go over here and I'm going to do the derivative and figure out what dx equals. So the derivative of u is du over dx equals 2x. Multiply both sides by dx, and then divide both sides by 2x. So dx equals du, can't really see it in there, but it was divided by 2x. So I ended up with dx equaling du over 2x. So that was my first step. Substitute out the u part and the dx part. Done. Now, the second part is to simplify, and if the problem works out well, your 2x and your 2x will cancel, so your x's are gone. And this is working out great, so I have u squared du. I've got it down to very simple, u squared du. The antiderivative of u squared is, so I'm doing the antiderivative now, is make it a 3, divide by 3, plus c. So I substituted, simplified, antiderivative, and the last step is just make sure you unsubstitute or plug this x squared plus 1 back in because the problem started with that and you want it to end with that. All right, I'm going to lump examples 2 and 3 together. So the reason is example 3 is almost the same. So it's integral of x squared plus 1 squared dx. So we're going to talk about the differences between example 2 and 3 as we work through. So x squared plus 1 squared dx. We have the same issue here, product, composite. I'm going to do the same u, x squared plus 1, because that's the inside of the parentheses, the inner function of this composite. Stealing the dx answer from the other one, I'm going to kind of fast forward and get du equals, or dx equals du over 2x. And that's just because I picked the same u as before, I can have the same dx. So I'm going to first substitute. So it's x, that's out, so it's u squared. Dx is out for du over 2x. The reason I picked this one, in addition to example 2, is I wanted to show you sometimes it's not as easy as 2x, 2x, and they're both gone. Sometimes just the x will cancel, and you'll be left with a number. Numbers are okay. X's are not okay to be left. So I'll show you in the future what happens when an x is left, but here I ended up with u squared over 2, and that's okay. If you have an extra number, you just slide it over in with the u function and we'll deal with it. So when I do my antiderivative, u squared becomes u to the 3 over 3, but there was already a 2 there. So when I simplify, it'll end up being u cubed over 6 because of the existing 2. I'm going to unsub as I simplify, so I'm going to plug that x squared plus 1 back in, and then over 6 plus C